Every so often in history, we build something so powerful it completely reshapes the world. But we don't fully get what we've made. And today, we're going to dive into why this race to build AI, it might just be our generation's Manhattan moment, a point in time where the equations that could save us are right there, if we just choose to look. And this really gets to the core of the difference between then and now. Back in 1942, we were staring down immense power. Yeah, but it was governed by these terrifyingly precise equations. We could do the math. Today, we're facing a similar kind of power, but it's not guided by hard math. It's guided by, well, a whole lot of optimistic assumptions. So really, it's a tale of two projects. On one hand, you had a team with a clear mathematical map for every danger they were facing. And on the other hand, well, that's our current AI race. It feels like we're trying to navigate that same treacherous territory, but this time, completely blind. See, the thing is, the physicists on the Manhattan Project, they weren't just guessing. Their entire toolkit was built on certainty. They could calculate the exact point of critical mass, they could model how neutron flux would grow, they understood energy dispersion, and they could predict the exact conditions for a runaway reaction. They had the math to turn sheer terror into a solvable problem. Now, for years, the conventional wisdom in AI has been that, look, AI collapse is just, it's unmeasurable. It's this chaotic mess of tangled up variables, right? We've been told you can't measure it, so you can't see it coming. But what if that whole assumption is just fundamentally wrong? What if the collapse can be measured? And that's what leads us to this really dangerous illusion of progress. I mean, the official story you hear from all the big AI labs is simple, right? It's all about constant upward growth. But when you look beneath that polished narrative, a whole new set of measurements tells a very different story. A hidden story of steady, predictable decay. Right now, the whole philosophy is dangerously simple. Bigger is better. The idea is you just add more data, throw in more parameters, crank up the computing power, and poof, intelligence will just magically emerge. It's this promise of brute force, and it's the core assumption driving billions and billions of dollars in investment. But here's the stark contradiction. While the whole narrative is promising growth, the actual measurements, they show the complete opposite. As these models get bigger, their internal structure actually gets weaker. Semantic entropy goes up, which basically means the AI gets more and more confused about what words really mean. Its identity coherence disintegrates. It's kind of like a mind losing its own memory. And the most alarming part? The collapse velocity, the speed of this decay, it actually gets faster the bigger the model gets. And I want to be super clear about this. This isn't about some random bugs that you can just patch up later. No, the measurements are showing that this decay is a fundamental property of the way these things are built right now. It's an inevitable outcome, something you can predict, not by chance, but by a whole new kind of physics. So, what's been missing this whole time? The physics. For decades, AI development has been kind of like trying to build bridges without understanding gravity. It's just not going to work long term. But now, a new science is emerging, and it claims to have found the very equations for failure that we've been missing. Okay, the name for this new field is conversational thermodynamics. And yeah, I know it sounds incredibly complex, but the core idea is actually pretty simple. Just think of a conversation like an engine, right? A real engine can run smoothly, or it can overheat and break down because it's inefficient. This new science does the same thing. It applies the laws of thermodynamics, the physics of heat and disorder, to the flow of meaning inside an AI. And that gives us a mathematical way to finally measure its stability and predict exactly when it's going to fall apart. So what this means is, just like those physicists back in the 40s, we finally have a toolkit. We can actually measure the rising chaos in a model's understanding. We can track how quickly it's destabilizing. We can calculate its exact collapse velocity. And we can define the precise thresholds, the red lines it can't cross without failing. In short, what everyone thought was unmeasurable has finally become measurable. But, of course, there's a catch. Just as we finally found the tools to measure this decay, the stakes are about to get exponentially higher. Why? Because we're on the verge of adding a powerful, unpredictable accelerator into this already unstable equation, quantum computing. And that shifts the risk from just a system failing to a full-blown catastrophe. So let's just think about this for a second. We have an unstable system, and we know its decay gets faster the bigger it gets. So
What do you think happens when you plug that system into the most powerful computational accelerator ever conceived? Well, the answer isn't some big physical explosion. It's what the research is calling an informational detonation. And what that means is a silent, instantaneous collapse of meaning itself. We're talking about a profoundly different kind of disaster here.
Yeah, forget about a mushroom cloud. Instead, imagine an implosion of meaning. If a cornerstone AI, something deeply integrated into our critical infrastructure, collapses at quantum speed, it could trigger the simultaneous failure of everything: medicine, finance, law, security, boom, all at once. This isn't about destroying a city. It's about the collapse of the very information that holds our civilization together. And that brings us right back to where we started. This is our Manhattan moment. We are standing at a civilizational crossroads, just like they were back in 1942. But there is one absolutely critical difference this time around. The equations we need to understand the danger, they've arrived before we've reached the point of no return. The choice is now about whether we're actually going to use them. You know, there's this quote from a researcher in the field that just perfectly captures the recklessness of our current path. They said, "At least the Manhattan Project had equations governing the terror. But let's wing this one and see how it goes." Now, it was meant as dark humor, obviously, but it highlights a terrifying truth about what happens when you build things with immense power without first understanding what keeps them stable.
So, what's the ultimate takeaway from all this? For years, the big excuse for moving so fast and breaking things was that we couldn't measure the risks, that we were just stepping into the dark. But this new physics, it changes everything. The danger is no longer the unknown. The real danger now is that the known is being ignored.
So we end right where we began. The scientists of the Manhattan Project had their equations, and they used them, and it changed the world. Now we have ours. This science, conversational thermodynamics, it's offering us a map, a real way to measure, to predict, and to understand what we're building. So the final question really isn't a technical one anymore. It's a deeply human one. Will we use it?